everyone. So welcome back to my channel again, Intelligent Learners. This is the name of my channel. Please find out on YouTube to get more videos on academic maths learning. Okay, this channel talks about the academics learning of subject mathematics only. As you know that we are going towards the notes of the first chapter, that is the real numbers. Okay, and this is maybe the third or the fourth video of the real numbers. So in this video we are going to learn how to find the HCF, which is the highest common factor of three numbers. Suppose in the previous video I told you, if you have two numbers, suppose you have 18 or 30, or maybe you have 420 and 130, how you will find the HCF? By using two methods. One is the prime factorization and the another one is the Euclid's division algorithm or lemma, right? So now if we have three numbers, so let's see how to find out the HCF of the three numbers. Okay, before that, please, if you are liking the videos, do subscribe to my channel Intelligent Learners and also share with others so that others also get some help through these videos, right? And yeah, okay, so let's start, everyone. So are we able to find the HCF of three numbers using only the Euclid's division lemma, or we have another method also? We have another method also. We have also learned in the previous video of use of two numbers. So let's start, everyone. So starting with the easiest method, that is the prime factorization method. The prime factorization method, right? And here we have three numbers. One is 18, one is 30, and one is 45. So in the prime factorization method, we have to divide the bigger number into the product of the prime numbers, right? Suppose we have 18. So when we will take the LCM, that is the least common factor of 18, so it will be like this. Like 18 is equal to, we can write as 2 multiply 3 multiply 3. Similarly, we have to take the another one, which is of 30. So 15, 5 3s and 3 1s are. So what is 30 prime factorization? 2 multiply 5 multiply 3. And of 45, that is not by 2, it is with 3 only. So just wait a minute. Yeah. So 3 15s are, then again with 3, 5, and 5 1s are 5. So 45 means 3 into 3 into 3, 5, right? Now we have to take the numbers which are common in all three. So we have a number 3, 3, and 3. It is common here, right? And is anyone other number? No, nothing is there. So it means 3 is the HCF. Okay, only 3 is common in all these three numbers. So it means 3 is the HCF. So this is the first method, or the simplest method that we have learned in the previous classes, in the small classes, how to find the HCF of three numbers, four numbers, two numbers by using the prime factorization method. And in this method, we just have to divide the bigger number into the product of the prime numbers, right? Now let's talk about the method which we take in class 10th. Big classes, right? So let's talk about that. Okay, so by using Euclid's division lemma. Okay, now for this, if we have three numbers, so we'll take first two numbers first. And what Euclid's division lemma say? That it says that dividend is equal to divisor into quotient plus remainder. Okay, this says that, right? Now, just a second, everyone. Yeah. So dividend is equal to divisor into quotient plus remainder, or in another form, we can say that A is equal to BQ plus R. You have learned in class 10 in the first chapter only many times that A is equal to BQ plus R, which is not other than, it is the same, that is dividend is equal to divisor into quotient plus remainder. So what is A? Dividend, B divisor, Q quotient, and R is remainder. Okay. Now, when we have chosen two numbers, one is 30 and one is 18 first, what we have to do, we have to apply this dividend is equal to divisor into quotient plus remainder using two numbers. So here the bigger number is A and the smaller number is B. So 30 is equal to divisor into quotient we have to find out. So when you will divide 30 by 18, so 18 to 36, 18 1 by 18 it will go. Okay, and the quotient is 1 and the remainder is how much? 12. Okay, now again, similarly, now what you have divisor, it becomes A in step 2 and it will become B. This is step 2, right? So in step 2, everyone, what we have, 18 is the dividend, 12 is the divisor. When you will divide 18 by 12, the quotient is 1. How? 18 divided by 12, 12 1s are 12 and the remainder is 6. Okay, now this will become A and now this will become B. So step 3 is equal to 12 is equal to 6 into 6 2 ja 12, quotient is 2 and the remainder is 0. When you will divide 12 by 6, the answer is 2 and the remainder 0. So when you will get remainder as 0, so what is the answer? This divisor is the answer. So it means the HCF of 30 and 18 is how much? HCF of 18 and 30 is 6. Okay, when you will have the remainder as 0, you will get the answer, which is this part, the divisor, right? Now, because we have 3 numbers and we have just taken the 2 numbers. Now, what we will do, everyone? We will take this 6 and now we will take 45. Okay, the other 2 numbers. So let's move. So first we have taken 18 and 30 and the answer of 18 and 30 HCF is 6. Now what we will do, whatever is the result of the first 2 numbers, we will take that number with the third number, which is 45. Okay, so let's move, everyone. Now HCF of 18 and 30 is 6. Now take 6 and 45. So 45, which is the dividend, the bigger number is the dividend and divisor is the smallest number. So when you will divide 45 by 6, so 6 7s are 42 and the remainder is 3. So it means the remainder is, the quotient is 7 and plus 3. Now this will become A, the dividend, and this will become the divisor. So this is step 2, everyone. So this is 6 dividend and 3 is the divisor. So when you will divide 6 by 3, the answer is 2 and the remainder is 0. Now when you will get remainder as 0, so what is the divisor is the answer. So this is the final HCF. So finally HCF of 18, 30 and 45 is 3. And we have also find out the same HCF of 18, 30 and 45 by using the prime factorization. The answer is 3 only. And by Euclid's division lemma also we have find out that the HCF is 3. This method, Euclid's division algorithm, we have used for the higher classes, and prime factorization method we have used in the previous classes. But you can cross check the Euclid's division lemma by the prime factorization also. Okay, if you don't have so much of trust on your answer, you can easily find out by using a rough notebook mein, rough page par, you can easily find out by using the prime factorization, so that you can cross check your answer whether you have done it correct or not. Okay, so by this we have find out the HCF of 3 numbers. So what you have to do, everyone, first take any 2 numbers, find out the HCF, and whatever is the result of these 2 numbers, take that result with the third number and again find out the HCF by using the same Euclid's division lemma. Okay, so answer of this HCF is 3. I think it's very much clear. You have to stop the steps when you will get remainder as 0. So the divisor will become the HCF. Okay, so thank you, everyone. Thank you so much, and please wait for the another video. Okay, and I will make an introductory video of myself, okay, very soon. So thank you.